This game will be developed step by step. If you want to follow along and create the same game, please watch the tutorial from the first video. If you're just interested in learning the basics of scripting in Unity, let's get started. Hi, I'm Lisa and welcome to my channel. Today we are going to create a few scripts that will bring our scene to life. You already know about components on game objects, which add the necessary properties. The main idea of creating your own scripts is to make your own components and systems that control various objects. To work with scripts, you'll need an editor, or IDE. Download Visual Studio Code or Visual Studio Installer from their official websites. For Visual Studio Code it will be sufficient, and the Visual Studio Installer requires additional setup, but I recommend using Visual Studio because it is a more powerful tool. Install Visual Studio Community with the additional Unity development component. After that, go into Unity, open the Edit tab, select Preferences, go to External Tools and choose your preferred editor. And I need to make it again. Create the new game object, reset its position and then place our character to this object. I rename our character to Side Animation Holder and the root object to Character. Now let's create our first clip. Right-click on the project window, select Create, C# script. Name it Input Controller. Drag and drop the script into the characters to ensure it's attached. Double-click on the script to open it in your preferred editor. By default, Unity uses several namespaces like Unity Engine, System Collections, and System Collection Generic. Next, you'll see your class, which inherits from one behavior. This means you can access summon fields, attach your script like component to any objects, and use various Unity events. The events are the methods you'll see inside your class. Start and update. There are many different events in Unity. Some are part of life cycle, as I mentioned earlier, while others are related to physics, rendering, and more. The start method is called when the scene is initialized for gameplay, and update is called every frame. Our first goal is to control the animations of our cylinder using the keyboard. To do this, we need access to the animator controller from the script. Here are two of the best and simplest way to do it. First, create a public field of type animator. Save your code and open the editor. You'll see the field appear in the component. Now you can drag and drop the animator into this field, then return to your code. However, making a field public is not always a good idea. It's best to make fields public only when necessary. In other situations, make the fields private and use the serialized field attribute to give the inspector access to it. But sometimes you might not want to use the editor or reference components. In such cases, you can use the getComponent method instead. GetComponent is a powerful method that lets you search across all scenes. Just specify the type you are searching for and the direction, like getComponent in children, or getComponents in parents. You can also retrieve multiple components using getComponents instead of getComponent. There are a few important points to keep in mind. First, avoid using getComponents in sections that will be called multiple times per game, as it can negatively impact performance. Use it during initialization, in start, awake, or your own initializing functions. Second, if there are no components overspecified, you could get a null reference exception. Always check if the variable is null or use the required component attribute before the class declaration to ensure the components is present. But required component only will work for getComponent method. Now let's talk about input. For simplicity, I suggest using keyboard controls and Unity's built-in input system. However, keep in mind that there are many options in Unity. So after you learn this, you might want to explore the input system package. It's more suitable for cross-platform development and touchscreens. Let's write this code in the update method. Input getAccessRow is a method that gets input variables using the row names you can see in the project settings window. If the horizontal axis is set to 1, it means the player pressed the right arrow key, the D key, or moved the joystick stick to the right. So we need to move our character to the right and set the animators to right trigger. Do the same for the to left trigger. Next, let's add jumping and edge standing. Use the vertical axis for this. Now let's run our game and see how it works. You'll notice it doesn't work very well. For an even worse experience, try holding any button and watch what happens. You can pause the video and think about why this is happening. The issue is that input get axis registers the hold, not just a single press, so our trigger gets set multiple times per press. To avoid this, add a delay for the next side movement. Create a float field delay, mark it with the serialize field attribute, and create another float attribute called timestamp. Set the delay to 0.7 and timestamp to 0. Now add this to your code. We'll check if enough time has passed since the last movement. The time class keeps track of the current time in seconds. Remember, the edge has a 1 second duration, so we need to add a new delay called edge delay and set it to 1.05 or 1.1. We do it because we need our delay a bit longer than the animation duration. Run your game again and test it. The delay works well, but if you hold 2 buttons at once, you'll see that your character keeps moving even after you release the buttons. To fix this, interrupt the code after performing at least one action by using return. Lastly, we don't want the cylinder to move left if it's already on the left, and so for right. Add states inside your script to handle this. Use an int variable for the state, 0 for the left, 1 for middle and 2 for right. You could also use an enum. Our second goal is to make the cylinder roll forward. There are several approaches to achieve this, and we'll start by using the update method. First, create a new class and name it movement. You can create a class right in the current file. Select the class, click on the screwdriver icon and choose Move Type to. Open the new file and add the update method to it. We use the monobehavior transform field to access the transform component. To move the character forward, use these constructions. Vector free, forward. This will change only the Z coordinate. Add a new field called speed and set it to 0.04. Now attach our newly added script to the character and run the game. On some computers, it works unevenly. This is the typical mistake when using update. It happens because update is called every frame, and as you may know, the number of frames depends on the computer's power. In 1 second, update could be called 120 times, and in another second, only 15 times. To fix this, multiply the forward factor by delta time, which keeps track of the amount of time that has passed between the current and last frames. However, in our case, it's better to use the FixedUpdate method. In the project settings, under the Time tab, you can see the Fixed Timestamp field, which by default is set to 0.02. This means FixedUpdate is called 50 times per second. This method is used for physical calculation, and since we will use physics for our character in the future, we must use FixedUpdate. Because FixedUpdate is called a fixed number of times per second, we don't need to multiply by a fixed delta time in our code. Next, let's create some decorations for our scene, like buildings, trees and bushes. Design this to your liking. I'll show you my approach. First, I added borders on the sides of the road. These are simple objects with a shader applied. We want this decoration to appear when the scene initialized, and we'll move the first decoration to the last spot during gameplay as the cylinder passed by. To do this, let's create a new class called Decoration Line. I added fields for the inspector: private game object decoration sample, private float step, private int max count, as well as Q to hold our decoration line, and vector free next point. Next, we'll need to handle initialization. I did this in the start method, but I had the logic inside a function called build. First, I initialized next point, which remember where our decoration will be placed. After that, I use a for loop to instantiate object based on the given decoration sample. The instantiate method creates a new object with specified position, rotation, and parent. Each instance is added to our queue, and I move the point forward before each instantiation. Create an empty game object at the border inside it and assign the border as the sample inside the decoration component. Now, if you run the game, the left border will appear in the scene, but we can do more. Add a content menu attribute and name it build. This allows us to build our border directly in the editor. However, if we run the game, the border will appear twice. To prevent this, we need a clear function. In Unity, you can remove objects and components using the destroy function. Unfortunately, you can't use it when the application is running. In such cases, use the destroy immediate function. Since our method will work in both scenarios, I used the generic delegate Unity action. In our clear function, I used linQ to separate one-level children and the get components in children method. It's fine to use these modern animating methods because they only code at the start of the game. So I added the clear function in the start method and create context build and context clear functions with the context menu attribute. As you can see, everything works nicely. When you start the game, the objects are cleared and replaced with new ones. When you stop playing, the original objects reappear. Next, I applied the same logic to the right side of the road. Let's dive into the runtime part. I added a float field called Delta and set it to 6, along with the transform field player, where we'll place our character. You can separate these fields into two parts using the header attributes for clarity. In the update method, I check if our character has moved forward by a distance greater than delta from the last object in the queue. If it hasn't, the method simply returns. If it has, we move the last object to the end of the line. Then moved on to the trees. I created a tree and tried to follow the same steps as before, but it ended up looking too uniform and unnatural. So let's add a variety option to our class. I added another header and fields, a boolean, add variety, and a float, variety strength. In a new if section, I use the random range function to rotate objects and move them along the Y and Z axis. The difference is significant even when using just one type of object. Now I've created 3 buildings because I want to show you how to work with prefabs in Unity. I created a folder and placed the first buildings in it. Unity highlights in blue indicating that any changes of the prefab will be reflected in all its instances. But I right-click and select Unpack Prefab, create the second building and save it in the folder. I repeated this process for the third building. Unpack Prefab allows you to change the object freely after it was saved as a prefab. Next, I moved on to the scripting. I created a new class called Random Decoration Line, which inherits from my Decoration Line class. I added a new method called getObject. In the parent class, this method simply returns decoration sample. Now, in the build function, we'll use this method. Back in Random Decoration Line, I initialized a serialized list of game object prefabs. I then overridden getObject to randomly pick an object from this list and return it. I did all the same preparations on the scene, created an empty object, placed the buildings onto it and built the line. I also added lines with bushes and that's it. But now we'll face a problem. What if the road ends? How can we extend it? The answer is we don't need to, just add the same movement script to our road and set its speed to match the character's speed. But I have to warn you that a runtime generated environment never match the performance of a pre-generated scene. For better performance, it's a good idea to generate the environment before the game starts. In the next part, we'll add the post-processing effects, camera movements, cozy lightning and particles. Stay tuned and I'll see you later.